All right, so continue on with our practice exam. This is part 2. We're going to find the sum of this monomial times the polynomial, and then these two polynomials multiplied together. All right, so we'll do it two different ways. The first way is to distribute this negative 3x into the polynomial. This is a binomial, of course. All right, so we're going to take this negative 3x and distribute it into the x and then into the 8 like that. Right? So when we do that, we're going to get a resulting, sorry about that, we're going to get a resulting negative 3, right? And then an x times an x is an x squared, and then we'll get a positive plus, we'll get a plus negative 3 times, sorry, negative 3x times 8 is going to be minus 8, 24. Negative 3 times 8 is 24, and then don't forget about the x. So that's what you get when you multiply negative 3x times a quantity of 8 plus x. Okay, now over here, we're going to make ourselves a little table for multiplying these two polynomials together. All right, so we're going to take our x and our plus 7. Remember, this is a plus x. And then we're going to have our 9 and our minus 2x over here. And you could put negative 2x up there if you wanted to. In fact, I'm going to do that just out of convention because it makes it all, that way it looks the same. And so this is a negative 2x and then a positive 9. All right, so multiplying these together would be the same as multiplying this and then this one and that one, and then you got a combination of terms that you have to consider and then add together, or combine together. Or you can do this. All right, so negative 2x times positive x is going to be negative 2x squared. Okay, and then we're going to have a 9 times x is 9x, and then we're going to have a negative 2x times a 7 is going to be minus 14x, and then our two constants multiplied together. 9 times 7 is 56. Okay. All right. Oh, sorry, 63. Now, where are my times tables at? 63. Okay, so now we can look at these two like terms, the negative 14 and the 9x. Those combine together, negative 14 and 9 combine together to make a negative 5x. Okay, so my resulting terms are going to be, in the correct order, negative 2x squared minus 5x, and then plus 63. Now I can just write that down in the right order because this is a plus sign. If this was a negative sign, I would have put all that down into parentheses and then flipped all the signs in this in another step. But I don't have to do that. I'll do that in the next question, I think. All right, now I have to add, or I have to combine like terms. Negative 3x squared, negative 2x squared is going to be negative minus a negative, making it more negative. So it's going to be negative 5x squared. Then we have a negative 24 minus a negative 5, making it more negative to a negative 29x. So we got these ones down. Those are done. These are done. And we have plus 63. Plus 63, and we are done with that one. So moving on to this one. All right, so this one has a lot of fractions in it, but the good news is the fractions all have a 4 on the bottom, on the denominator. So it could be worse. All right, so what we're going to do here is distribute the 3/4 into each one of these terms. And then we're going to see if we can combine like terms here. It doesn't look like we can, right? But we do have this negative sign distributed into each one of these terms. So our next line is going to consist of 3/4 multiplied by everything in here, and then flipping the sign of each one inside this, these for all these terms. Okay, so let's do that first. We'll make our constants green, I guess. So 3/4 times 5 is going to be 15/4. Okay, then we still have y to the 4th minus 8. Well, I'm going to rewrite this. I'm going to rewrite this as this. 15/4 y to the 4th. Okay, minus. Oh, just going to make this minus. Make y as burgundy. Minus 8. So this is going to be 8 times 3 is 24. 24, and then it's going to be y, just regular old y, divided by 4, and then we're going to distribute this negative sign to everything else in here. Okay, so we have a y to the 4th. Hey, here's a y to the 4th. We're going to make this one red, right? So our y to the 4ths are red. Okay, so this is going to be 11. It's going to be minus 11 y to the divided by y to the 4th. Okay, plus y to the 3rd. That's a new color. We'll make this one pink. Plus y to the 3rd over 4, because 1 times y to the 3rd is just y to the 3rd, and then we have to swap that to regular old constants, 15/4. All right, so this is going to turn into just red, because this term is my y to the 4th term, and this is a y to the 4th term. Okay, and then this is a pink, y to the 3rd term, and then this is a burgundy, y to the 4th term, so it's 24y. So, okay, so now we have our colored like terms. Okay, so now I look to see what terms I have that are of the same type. Okay, so I have a y to the 4th and a y to the 4th. Okay, so where did I get that? This should be 11 y to the 4th. Double checked. This is 11 y to the 4th. Glad I double checked that. 11 y to the 4th. It's minus, plus, minus. Make sure I don't have any transcription errors from all my color coding. Okay, 315. Okay, all that looks right. Okay, so now I know that I can combine. The denominators are all the same. Right, so if the numerators have the same variable and the same exponent, so like this one and this one, right, I can combine those, just like if they were like that. Okay, so now I can combine 15 and negative 11, making it, let's see, 15 minus 11 is going to be 4 y to the 4th divided by y to the 4th, or just divided by y. Okay, and then nothing else really has anything, so I'm going to put it in proper order. My plus y to the 3rd over 4, and then minus 24y over 4, and then minus 15 over 4. All right, so now I can reduce. Stuff. 4 over 4 is y to the 4th. This is still I'm just going to say this y over, I could recall this like 1/4 y cubed. I'm just going to still say y cubed over 4. This could also be written as 1/4 y cubed. Okay, 24 divided by 4 is 6y minus 6y, and then 15/4 is still 15 is minus 15/4. So there you go. That is your answer there. Okay? So there's that one. So this is your answer right here, and you could substitute. You could change this into, like, let's see, 15/4. 15/4, you could convert that to 3 3/4 if you wanted to. It's the same. It's the same. All right, let's move on to number 11. All right, so let's do this 2 ways here. Let's do it with the distribution method, where we go 3x times 4x. That's going to be 12x times x is x squared. Right, that makes a new type of variable term. Then we have an 3x times -6. It's going to be negative, right? -6. That's going to be -18x. And let's shift to our other term. So we have a 7x, or 7 times a 4x, right? So we're going to get a 7 times a 4. That's going to be a plus 7 times 4 is 28x, right? And then we have to do a different color. Then we're going to do a 7 times -6, which is 7 times 6 is minus 42. All right, so that's just kind of distributing the polynomial to itself. These two terms here are alike, as you normally know from multiplying two polynomials. -18x plus a 28x is going to give you a positive 10x in the middle there, and then from there the 12x comes down, 12x squared comes down, and then the minus 42 is left over. Minus 42 is left over. That's the one way to do it. Okay, and then the other way to do it is to set yourself up a table like this with the terms from each split up. Okay, so we have our 3x and our 4x, right? And then we have a negative or a positive 7 from there, and a -6 from here. Okay, you're always going to have an x squared when you multiply an x times an x. So it's going to be a 12x squared. That's where that one comes from. Okay, and then let's multiply these ones together. 6 times 7 is -42, and there's our one constant term that gets spit out right there. So that's your -42, and then you're going to have the combination of two x's, right? So your 3 times -6 is -18x, and there's that one. And then we have our 4x times 7 is 28x, and there's that one. These two added together become, or combined together, become 10x. So there is your solution, right? Your 12x goes there, your -10x, sorry, your positive 10x goes there, and then your 42x, -42 goes there, right? In standard form. Okay, biggest exponent, second biggest exponent, no exponent. Okay, next one, we have x plus 5 quantity squared. All right, so this is pretty easy. You can expand this to be the same thing as x plus 5 times x plus 5, because that's what happens when you square something, is you multiply by itself twice. Okay, so if we do that, you know, our x's are our green factors, well, anyway, I don't remember what color. Yeah, X was green. This was green, green, green. And then our reds were our constants there. Reds. Anyway, so our x times our x becomes a new type, x squared. All right, and then we have, we're just going to be green because we're doing an x. Go ahead and do this. X times x is x squared. Then we have a green times a red, and that's just going to be another green because it's going to be plus 5x. I'm going to do that again. X times 5 is plus 5x. And then we're going to do a 5 times a 5, which is a 25 plus 25. Combine these two together, and you're going to get x squared plus 10x. I color code it. Plus 10x plus 10x plus 25. All right, so that's one way to do it. And then again, you could do it using this method and it would be the same. Okay, I'll do it real quick, I guess. So you have an x plus 5. What color were my x's? An x, and then a plus 5, and then a plus 5. X times x is burgundy. X squared. Then you have x times 5 is x, 5x. And another 5x. Combined together, we get a 10x. And then you get a 5 times 5 is 25. Combined all together, you get this. Okay, so finally, another way to do something squared, right, is if you have something squared, you're going to take the first term and square it. Take the sign of the constant and duplicate it. Okay, and then multiply the two together, which is going to be, and then double it, which is going to be 10x. Okay, so multiply the two together and double it, and then square the second term, 25. Another way to do that. That's a quick way to do it, right? So step 1, square first term, square it. 2, transcribe the sign of second term. 3, multiply first and second term, double answer. And then 4, second term squared. All right, so there is your shortcut to that, how to get that, which is pretty neat. All right, number 13. Okay, we're multiplying these two things together here. Okay, multiplying these two things together here. So this, I guess I'm gonna do this. This is the numerator. Okay, so my constants are going to be 3. This is all over 4. Okay, that's my numerator. Then I have this will be b to the 7th, right? Parentheses 13. I'll make that. Yeah, 13b. That's a b term, and then minus 12 is another constant term. Minus 12. Okay, I just rewrote that. As like a common fraction. Okay, now I need to distribute 3b to the 7th into this polynomial. Okay, so 3 times 13. 3 times 13 is 39. So first line. This is going to become 39. Okay, it's going to be a red one because it's multiplying by b. And then b to the 7th times b to the invisible first is b to the 8th. Okay, my minus sign is going to become a b again because I have a b that it's multiplying by. 3 times 12 is 36. And then there's no b here, so it's going to be b to the 7th. Okay, and then nothing on the bottom is 4. All right, so that is that one. So now can I divide anything else? Well, this is going to be equal to 39. These aren't the same. B to the 6th, B to the 7th, B to the 8th, those aren't the same. So I can split this into 39 B to the 8th divided by 4. I can make this green. I can make this green again. Make that green. 39. I can make, oh, that was 36. Was it? 3 times, no, that was 39. 39. I can make this 39. 39. 39. Okay. 39 divided by 4 is still 39 divided by 4. It's nothing crazy there. I could convert it into an improper fraction or into a proper fraction, but I don't want to. Okay, and then I can make this minus 36 b to the 7th divided by 4. Yeah, okay, well that can be green. Okay, 36 divided by 4 is 9. So this becomes 9 b to the 7th. So like completely done. This becomes, in just black and white, 39 b to the 8th divided by 4 minus 9 b to the 7th is your like fully like complete done answer, b to the 8th. Okay, so there's that one. All right. So here's saying, hey, h isn't 0, right? That way you can't have a 0 in your denominator. Right, so this is fancy, right? This is the same thing as writing same. Okay, don't make it throw you off. Okay, and if this is, oops, yeah, you can see it. So if that negative sign is in the denominator, it doesn't matter. It's in front. Okay. Who cares where it is? So that's the same. Okay, same as everything. Who cares if the division sign is written like that? This is the same. Okay, so now you can just rewrite this as this. Okay, so it's going to be negative with the thing. Okay, and we'll write our constants: 21, 7, 35. We'll make it a plus sign, why not? And then we have h to the 12th, h to the 3rd, and h to the 21. All right, well, 21 divided by 7 is 3. 21 divided by, or 35 divided by 7 is, well, that's 6. I think 35 divided by 7 is 5, excuse me. I don't know my multiplication tables. This is 5. 5, and then 7 divided by 7 is just 1. Right, so I'm just going to make that 0. I'm just going to erase that. Okay, so my new thing is going to be, my new line is going to be going to look like this. 3 plus 5, didn't touch the h's yet, h to the 12th, h to the 21st, h to the 3rd. Okay, so now I'm going to work on my h's. Okay, so I have common h's here, and let's see, that one could go to war with that one, and that one, and that one, right? So here I got 0 left, so this one can go to 1, right? This 3 takes out, let's see, 12 minus, that's 9, and it takes out 21 minus 3 is 18. Okay, so now I can take out that, and it's going to be equal to, so this whole thing is now 1. Okay, so now my answer, final answer is negative 3h to the 9th plus 5h to the 18th, right? And that is going to be my answer there. Okay, that negative sign, that h can get distributed to both of those. Okay, and then I think this is our last page. Yep, last page. All right, so this one's easy. Okay, we'll do a table for this one because everyone seems to like the tables. Okay, we have, and green has been my x's so far, so we have an x and another x, both are positive. Okay, our x's and our x's from both polynomials. Then we have a negative 6 and a negative 5, a negative 6 and a negative 5. X times x makes a new term of x squared, and then a negative 6 times a negative 5 makes a 30. Okay, now we've got to figure out our x terms are going to be. All right, that's going to be negative 6x. That's going to be negative 5x. These two terms together combine to make a negative 11x. All right, so now our total terms, putting them in order, are going to be x squared minus 11x, and then this is a plus 30, and we are done there. Okay, there's that one. All right, now we got to do the quotient. Quotient of this. W and y are not equal to 0 because that would make the denominator a 0 and therefore making this undefined, which we can't have. Right, so first thing is first, anything on the top that we can simplify, W7, nope, nope, and nope. So let's look at our constants. Our constants. Okay, is there a common factor amongst our constants that we could get rid of? Prepare our line. Well, 5 divided by 5 is 1. So let's make our W's red. W's. And let's make our, let's see, how about blue for our Y's? Y, Y, and Y. Okay. And then don't forget to bring down the proper signs. All right, so we got a plus sign and a minus sign, and that's it. All right, so let's look at let's see if we can divide everything here by 5. That's divisible 5, that's divisible by 5, that's divisible by 5. So 5 divided by 5 is 1. All right, so I'm just going to bring down the W and the Y squared. W and Y squared. Okay, Y squared, and the W's red. Okay, 20 divided by 5, well, that's 4. 15 divided by 5 is 3, and then 35 divided by 5 is 7. Okay, so that's those ones. Okay, so now so this is a 1, right? Let me go ahead and erase that stuff. When I write stuff behind it, I can erase the 1. Okay, now let's look at our W's. Okay, all the W's on top versus the W on the bottom. This one's gonna take out all 3 of them. Okay, so this one W is gonna go away, but it turns this one into a W6. Gonna turn this one into a W because it's minus 2. It's gonna turn this one into a W to the 3rd. All right, my W's are done. Okay, now how about my Y's? This is a Y squared. Okay, these Y's are going to disappear. So no Y's from there, because that's Y to the 0th, and that's just going to be 1. This Y is going to take this down to a Y to the 1st. So that's going to be Y to the 1st. And then this one is going to become y to the 8th. Y to the 8th. So this is y to the 8th. All over 1, which then becomes just that. And I'll put a happy little box around that. And that's my final answer. Okay. So pretty simple. I can erase that 1 right here if I wanted to. It's not wrong to leave it there, but it's just extra. Okay, so that is that. I hope that helps understand the practice exam. If you have any questions, please let me know.